Let's look at an application of bilinear interpolation to double the size of an image. That is, taking an image of certain dimensions, I want to produce a new image that's basically twice as big. So interpolation, normally we think about in the particular linear interpolation, okay, would be something like this. So I have a point here and it has a certain xy value. I have another point here with another xy value. And if we think of a line as being between these, I want to be able to interpolate to find values along this line. So if we said, okay, for this particular x value, what would be the y value that produces that? And to find that, we would simply just find the slope of the line that fits these 2 points and then figure out how far out to go to get the appropriate y value. The bilinear interpolation, though, will be basically the same idea, except whereas this right here is a function of one variable, f of x will be equal y to figure out where I'm at here. For my image processing, I'll have f of, say, or row column. That will then give me the intensity or the image value at that point. So how am I going to do this? Well, let's say our image had these values right here. I'm going to write it like an array or a matrix. So A, B, C, D, E, F, G, H, I. It doesn't have to be square. I'm just limiting how much writing I have to do. What I'm going to do is take these values here and sort of spread them out. And so I'm going to start off by creating an array of all zeros and then populate it with these initial values. So I'd have A here, and then I'm going to have a 0, and then a B. Actually, it would be all zeros, but I'm overwriting some of the zeros. So that after I do that, then I would have this right here. So we see there's an original value, a value, a value, 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 value. I've just sort of spread this out. So what are the dimensions of the new thing? Well, if I look here, I had 3 values, and I placed a 0 essentially between each value. So if I have C columns, in the original image, this has what? C plus C minus 1 columns, which can be rewritten as 2C minus 1. And likewise for the rows, here's C, F, I, that's 3 values. I have 1 less intermediate values, so that will end up being 2R minus 1 rows in the new image. And once again, it doesn't have to be square, that's just how I happen to write it. Now, what will I put in the values where I currently have zeros, since I know what to populate for the others? Well, for the values on a row that has existing values like A, B, and C, I'm going to take the average of the left and right values. So between A and B here, I'm going to use A plus B divided by 2. Okay? And between B and C, I'll use B plus C divided by 2. What about between, say, F and I? Well, when I'm working down a column, I'm going to do the same type of logic. So between F and I, the new value would be F plus I divided by 2. And likewise between E and H, and B and E, and D and G. So I've taken care of the values on a row that contains existing values. I've taken care of the values in a column that has existing values. But what about right here, and here, and here, and here, where they're in the brand new row columns that don't have anything above and below it or to the left or right of it that was existing? But what I'm going to do there, like if I look in this lower right-hand corner here, where I have this, I have E, I have F, I have H, and I, and I'm going to fill in this spot right here. Well, I'm going to take the average of these 4 values. So this value right here will be E plus F plus H plus I divided by 4. And I'll do that for all these values and then save that as a new image. Let's see how well it works. So first I want to sort of demonstrate what I just said in isolation from the rest of the code. So I've written this little sample program here to create this array. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to print its shape, produce an array of all zeros with the correct dimensions, and populate it using slicing in Python. There's my array. So since this had 3 columns, this should have 2 more, so for a total of 5 columns. I have 4 rows, so it should have 3 more for a total of 7 rows. So here's my array of all zeros, and now I took these 12 values and populated them or transferred them to the appropriate positions in this array. So there's 1, skip a spot, 2, skip a spot, 3, just like I have here. And if I look at the last column, 3, 6, 9, 12, there's a 3, there's 6, 9, the 12. So it looks like it's working, and then you can see the dimensions here, 4, 3, 7, 5. All right. So how's the slicing work right here? So when I say A, 0 to R, 0 to C, this is okay from row 0 to row R minus 1. There is no real row R because in Python, arrays or lists, these are NumPy arrays, but it would also be true for a Python list, indices start at 0. So this is column 0, column 1, column 2, column 3, column 4. There is no column 5. There's 5 columns, but we start counting at 0, and therefore the last column is 4. Just like the last row here will have an index of 6 since we started at row 0. So when I write 0 to R, this says starting at row 0, and as long as you're still less than row R minus 1, increment in steps of 1, because I don't specify the step size. And starting in column 0, and while I'm less than column C minus 1, increment by steps of 1. That's to get these values here, because I want to get every one of these for every row, every column. But here, I want to start in column 0, but then jump to column, what is this, 2, right? Because this is 0, 1, 2. 3, column 4. Start at row 0, row 2, row 4, row 6. I want to jump. So this says starting at row 0, as long as you're less than row R new, that's my new dimension here, from 0 to row R new minus 1 in steps of 2. And likewise for the columns, go in steps of 2. So we'll initially assign a value. So A00, which will be the 1, will be assigned to B00. And then I don't know if it moves down a row at a time or across a column at a time, but let's pretend it's across the first row. This then would increment to row 0, column 2 to get element 0, 1 from array A. And it repeats getting these values. So part of this I did was for me to test out the slicing to make sure I was really thinking about it correctly. So let's look at the entire program. So I'm using the NumPy library like I was a moment ago, but I'm also using the Python image library, PIL. So if we go down to the bottom, I had this test case. Let's test it out, make sure everything was working on the interpolation. Because here I'm not interpolating, I'm just showing you how I'm initializing the values. The interpolation would fill in all the zeros. So here's my test array, and I picked numbers that let me easily check the math. So what would be between the 1 and the 3? Well, it should be 2. Between the 3 and the 5 should be 4. Between this 1 and 3 should be 2. Between this 3 and 5 should be 4, and so forth. What about between the 1, the 3, and the 5? Well, 1 and 3 is 4. 3 and 5 is 8. That's a total of 12. So 12 divided by 4 should be 3. There's my 3. So it looks like it's working. So now that we've tested, we can process an actual image. And we'll look in a moment and see, but my input image had rows, or had 130 rows and 73 columns. 2 times 130 would be 260, but remember we subtract 1 for the number of rows in the new image, so it's 259. 2 times 73 would be 146. So 1 less than that's 145, and then each image is a color image, so it has 3 layers, and that's true in the new one as well. So let's go up the top. So the first thing I'm going to do is I'm going to call resize image. So resize image will first open up the file that it's given right here, and it's of type image. But I want to process it with math, so I need to convert it to a NumPy array. So I'm using NP because I shorthand NumPy as NP, and I say np.asArray to convert image 1 into ODE. So ODE is a NumPy array. It's of type ND array. I get its dimensions, rows, columns, layers right here. And now I'm producing my 3-dimensional array of zeros with the appropriate number of rows, appropriate number of columns, and 3 layers. And then we'll print that out, which we saw right here. Then for each of the 3 layers, I'm going to call resize layer. This is where the interpolation is happening. So I'm going to take the first layer. So these are in RGB values, red, green, blue. So I'm taking the red component, I guess, then followed by the green, then the blue, and process that and put it in this new array. So this would be layer 0, layer 1, then layer 2. The problem, though, when I do this, is that the values then will be floating point numbers, and I need to convert those to 8-bit unsigned integers. So that's what this does. I'm going to take new, which is once again is a NumPy array, and I'm going to convert each of the elements from type float to type 8-bit unsigned int, and resave it using the same name. Print its dimensions, which I could have done even before this. We can see these right here. And then I'm going to convert that back to an image in terms of the PIL library format, append big dash to the beginning of the existing name, and then save a file with that new name. So originally I had this right here. Before we look at the interpolation, let's go ahead and look at the images to see how it works. So open book, faucet, and there's its dimensions, 73 by 130. Let's open up the processed version, open big dash book. And of course I can reshape it, but here's the true dimensions, 145 by 259. So I can tell this program here to blow it up. So they look like they're basically the same size now in terms of what I can see, but what's actually stored on the disk is 73 by 130 by 3. This is 145 by 259 by 3. They look basically the same. If I keep blowing this up, you can see this actually in some ways is a little bit smoother because I interpolated between values and got some intermediate values that were halfway there. But of course when the image is still small, you can't quite tell. Okay, so it looks like it actually worked and produced something that looks pretty good. Let's see how it works. So remember, I'm calling resize layer for every one of the layers. So I'm going to get the dimensions of the original layer. That's the 73 by, or 130 by 73 and what we saw here. I'm going to produce the dimensions of the new image. And now here's where I produce a 2-dimensional array of all zeros. Why not 3-dimensional? Because I'm processing it a layer at a time. So here's where I'm going to process that first layer, which would be a 2-dimensional object, and then I'll do the same thing for the second layer, then the third layer. Now Python supports slicing, so that's what I'm doing here. Okay, so we can say let's do this. That makes more sense. Here's where I'm moving the O points. Now in some languages like C, I wouldn't have slicing as an option. So instead I would just nest loops. So here's the code to do that basically. For each row, for each column, go through and copy the values over. What about the vertical values? Going back to what I had here, if I wanted the values between C and F, right here, or F and I, or A and D, what I'm going to do is find the average. Now, in the beginning, since these values aren't here yet, it doesn't matter if I do this for every column. So I can take A and D, I can take it 0 and 0, B and E, 0 and 0, C and F. It was just easier to write the code that way, even though it takes a little bit longer to run, but I can't tell the difference. And actually, I'm finding the average of 0 and 0 and writing 0 here. And then when I process the rows, I'll take the average between A and B and populate here. And then the average between this 0 and this 0 will be 0. And D and E will be here. And then the average between this 0 and this 0 will be here. But once again, it doesn't hurt anything. And then finally, I'll fill in those other values using this logic right here. So coming back down here, so here's the vertical values. I use slicing. So I'm starting at row 1 in terms of what I'm populating, not row 0, because that's where I'm getting a value from. But I'm in the first column, so this right here says for all columns. So when I'm processing row 1, which is really the second row, I want the value above it, which is row 0, and I want the value below it, which is row 2. And then I'm going to jump down, because here I'm doing step size of 2, same thing for here, same thing for here. But I don't want the rows to keep going. So for this right here, I need to make sure this stops prematurely so I don't go too far. Here's the alternative approach. Okay, so we can delete some of these lines as I read it to condense the code. Then I'm producing for along a row, I'm filling in the new column values. Same thing with the slicing. Now for every row, starting at column 1 in step size of 2, go across, taking the value to the left, which has column 0 index, and the value to the right, which starts off at column 2 index. And then I'm dividing these by 2. I forgot to say it for here, but I'm dividing these by 2. Okay. In the version of Python I'm using, which is Python 3, this will give me a floating point number. All right. So this fills these in. Here's the alternative code. And then finally, this was the hardest part to think about in terms of slicing. I want to fill in those center values that uses 4 values. So I'll start at row 1 and column 1 instead of column 0 and row 0 in step size of 2. So I need to make sure I stop at the correct value over here. So I'm starting in the upper left, which is row 0. Take the value to the right of that, which is also row 0, but this will be starting at column 2. Or actually, sorry, this would be column 0. This would be row 0, column 2. This would be row 2, column 0, and row 2, column 2 for the initial left-hand corner. And then all this is divided by 4. And if I were to get rid of the alternative code that you would use if I was doing this in C, or you could use it in Python, because I really did use that at one point, we would have this. And taking that out, you can see this is really all it took in Python to do the interpolation. If there's a way to condense this down into a single line, I couldn't figure out what it was, right? But that's all it takes in Python, because it's doing really the hard part. And we saw what happened. The image it produces looks pretty good. So that's bilinear interpolation.